This video will begin our process of learning how to use the programming language C, and we'll be using it in a command line environment. So here's our command line environment to work in right here. I am logged into the NAU Cephin system here, and so I'm on one of their 3 servers that you might land on here. But I want to start from scratch and point a couple of things out. So I'm going to start right here with a directory here. I'm going to make dir, and my directory is going to be examples. Now that's a make dir, that makes a directory. If I do an ls here, which is a list, then I will find that I have documents, which I have some other ones here. I will have the examples that I just made, and I also have my website materials here. Now to get into that directory, you'll do a change directory or CD, and you can do an examples, but if you get a couple letters into it and press tab, it will finish it for you if it knows what it's supposed to be. So here we are in examples. Alright, and if we do an ls here, there's nothing in there. We will go ahead and make a directory, and we'll call this program 1. I'm going to do an underscore there. And now we will be able to we can look at that with ls and see our program 1, and we can go there by typing in a couple of letters, tab, and now we're in program 1. So what I want to do now is I want to go into an editor, and I can go into an editor here by creating a file. If I have a file, say for example prog1 C, this is the VI advanced kind of editor here, and we can in fact do our programming in this editor. It's a little tricky because you have to know all the tricks and all the comments for it, but it's certainly doable. If I press the letter I, then I can start entering this right here, and I can do a pound include stdio, and it's actually .h in this particular case, and we can move on from that. I can create my main here, and we'll leave it as an empty main for the moment. We'll return a 0, and so on, to create this whole process here. Now to write this, for anything that's going to come out, first of all I'm in insert mode, the little letter I. So if I press the escape button, that takes me out of insert mode, and I'm back in what we call command mode. And what I can do from here is I can do a colon, and I can press the letter Q to quit, but it's going to complain because I did not change the file. I haven't saved it. So what I can do here is I can do a colon, and I can do a W for write, and the truth is I can do a W and a Q, which tells it to write and quit. Now with this in front of us for the moment here, this is an editor we can use. It's not very graphical, it's totally keyboard and text, but if you do have a couple of settings on your computer, you at least get color in the text. But I'm going to move to another editor that's a little bit easier to use. So we are going to save this file, colon WQ. If you look right down here, colon says here's a command. I want you to write this, and then I want you to quit. And in fact, that's what happens here. This brings us back to the command line that we see here. And again, we have our ability, we can list here. We now have prog1 C. If I open it up with Vim, I can see it inside here. But I can also open it up with another editor that is in fact a GUI editor. It allows us to do a little bit more with the pointer from the mouse and some other things like that. But this is, because it is GUI, it's not going to be on the command line anymore. It's going to be in a separate window. And this is implemented by some tools that you can get, we can discuss outside of this particular presentation. So I'm going to do a gedit. That's the name of the program. And I'm going to put prog, and I can just hit the tab letter and get that there. But I'm also going to hit an ampersand here. Now what this does is this allows me to keep control of this command line. If I don't put the ampersand here, I will in fact open the editor. That'll work just fine. But when I come back to the command line here, when I come back to this part here, I won't be able to do anything. And because I want to be able to compile the program, I want to work with the program on the command line here, I want to have access to the command line. So I'm going to do the ampersand, and this effectively says let's do this in parallel. So here I go, I'm going to press this enter here, and this will bring up my GUI here. Now, on the command line itself, you'll see some warnings. It's trying to save some recently used materials here. We don't really care about this. You'll notice if I press enter here, see where the cursor is. If I press enter, I'm back to the command line and I have access to it. But I also have access now to the GUI window here that puts me into play. And you can see I've opened up the file that I was working with just a little bit ago. Now in our main here, we're going to go ahead and take a look at a simple program. We're going to do some design work first, because even though this is an amazingly simple little program, you are going to get into some fairly complicated programs a little later on. So I'm going to throw some things in here to give us some support here. So I'm going to have a function name, and that will be main. Main is always the driving function. It's the one that will be called initially in a given program. I'm going to have an algorithm, and that algorithm is we're going to accept two integer values, add them to a double sum, and then we're going to then display the results. My preconditions for this particular function are none. There's nothing in advance that's happening to this. We'll discuss that more later. My post condition will be that I will return a 0 on success. Now that's not the program. The program is actually going to take the values in and add them to a double sum. But the main function itself is really, and in this case the main function is the whole program, is really going to just start with nothing, and when it gets done it's going to return a 0 back to the system. Okay, I'll go ahead and spell success correctly here. And we're going to do exceptions here. We'll have none, and then we'll have notes. Now this is just going to demonstrate input, output, and simple math. There is one other thing we are going to put into this a little later on. It tends to be kind of optional. We're going to leave it out for the moment, but we will discuss dependencies a little bit later on. Now what's the program going to have in it? Every function we start, we initialize it with the right keys. So I always start my functions with initialize function and variables. And in this function we're going to display a title. I'm going to get input from the user. I'm going to add the values. And then I'm going to display the result to the user. And I usually have some kind of shutdown for the program which incorporates this return 0. We'll come back and talk about that. Now this is a piece of a thing called the 6-step programming process. I'm not going to go into great detail on this, but I'm going to use it so that you have a chance to see how this can be used when your programs become very large and non-trivial, as they will for this operating systems class. With that in mind, this was step 1. This is the program. If you follow the instructions here, this is exactly what the program's going to do. But what I want to do now, first thing I want to do is I've got an asterisk right there, so I'm going to save this guy. I want to save it as often as I can here. But now I want to break the program down just a little bit more. So my initialize function variables doesn't have much to do. My displaying of the title is just that. But my getting the input from the user now, that's going to require a little bit more here. So I'm going to get the augend, that's the upper number in addition. And I'm going to get the addend, which is the lower number for the user here. And then I'm going to add the values, and again that's going to be simple addition. And then for my display result to user, that is also going to be a simple operation. So that's kind of our step 2 here. Our step 3 is we're going to go through and identify the functions that we need to use, the tools or modules. And by the way, note that I use nothing but the space bar here. If you use tabs and other people look at your code in other editors, it's very likely that your code is going to be splattered all over the place. Your smart money is to simply use the spacebar key and leave the tab key to the command line when you're trying to make words print out. Okay, so our display title now, the function we're going to use for that is simply going to be printf. Our function for getting the augend now is going to be, we will use the function printf because we're going to print a prompt, and then we will use scanf to actually get the input. And in fact, we're going to do that twice. Notice we can do the same kinds of things we do with window. I can do a Control-C and a Control-V. So that's very handy here. You can't do that in some of these other items. And so in the command line operation. The add values is nothing but math. We don't have to sweat that. But when we do display our result, we will in fact be using printf for that. Okay, so that gets us through our third step of this development operation. Again, this is a trivial program, but again, you're going to be on your way to non-trivial programs very soon. Now we come into the fourth step of this operation where we're actually going to write the code for the main function. I'm going to come in here to the title, and I'm going to printf, and I'm going to do a \n, which gets us an enter. It's a new line is what it is. And then I'm going to type in the title. And then to make it spiffy, I'm going to put an underline under it. Not a real fancy underline. How about we just do equal signs here? I'll do it up to there and back a couple so that it will be exactly the same width as the addition program. And we'll put our double quotes onto the end of that. We will go ahead and do a \n first actually, and quotes, and then we'll do our parentheses. Okay, so this is our addition program. One of the things that's a smart money to do, and again this is trivial, but it's a good idea right now to check things out and compile regularly. So I'm going to put this aside for a moment. Here's a mistake. I want to take this out completely, and then I'm going to go ahead and compile here. And we'll come down to here where we'll press enter here. So I will begin the command line operation here. We will start with GCC. We'll throw in a -wall, which is a -W for warnings. It says to show all of them. We're going to all code with the same standard here. So we're going to code with a standard C99. And then we do our pedantic, which just means take that very seriously. And then we need to put in our program name, which is prog1c. And then we want to create a program name called, we'll just call it add program, for example. Doesn't matter. We can call it anything you like. If you don't do that, you'll get an A out, which is kind of boring and dull, but you'll get that. So I'm going to run this compiler here. This is a command line operation here. Again, to repeat, GCC simply calls for the standard C compiler on this system, whatever system I'm on. I'm going to use a standard of C99 and be very serious about using that standard. And then I'm going to use this file here, and I'm going to turn it into the name of this program. Now when I put it into here, it says prog.c, no such file as directory, so I must have messed up the directory, and I have a prog1c. Now, what I want to point out here is what I did here is I had a capital P, and this is a lowercase p, and in the case of Linux and Unix, this is very important. It takes capital letters and lower letters very seriously. So you have to do it exactly the way it says to do it. Now, I'm going to use my up arrow key here, which takes me back to what I was doing before. I'm going to take my P back here and then take that, and then I'm going to press enter again. Now, it's going to say implicit declaration of this function printf, which is kind of a weirdo way of saying, wait a minute, I don't know what you're talking about. I don't know what printf is. So let's go ahead and go back to our program here. And what I took out here at the top is it's essentially like an include or an import or whatever. It tells us we have to include something for the input operations. So it's a pound include standard io.h and a bracket. And I'm going to save that, and then I will go back to my command line here. Bring this back to the same thing using that up arrow key. That's handy. And now it is compiled. And if I show the ls here, I will show you that I have add program. Not all systems do this, but this system shows you an asterisk, which is a way of saying that this is a program. If I do a /add prog, and remember I've got to keep all my upper and lower case characters exactly the same, then in fact I'm going to get that title that's written and run. So we've played on the command line. Let's come back and look at our program. We come down here to get input from the user here. And for our getting of our augend, we're going to do two parts here. We're going to do a printf. We're going to do a \n. This just jumps it down another line. And we're going to have the enter augend with a space. And then we're going to do a scanf. And scanf looks like a printf in the sense that I have to put something between quotes. But what I have to put between quotes for scanf is I have to say, here's the data I want to get. And the data I want to get is simply an integer or a decimal, we'll call it. It's %d is the character that we'll use there. And that's all I'm looking to get. Wrong character there. And then I'll put my comment. Now that %d requires that there be a parameter behind this. We'll find that it's the same thing for printf here later on. So %d, I want to get a value. I'm going to get the augend. And in scanf, this right here is essentially the same thing as saying send the address of this variable. And what will happen is with the address goes down into scanf, inside scanf it's a pointer, and it will place the data in there. Now obviously I need to take and create a variable here, so I will put my augend at the beginning here. Our standard rule is to declare all our variables at the beginning of the functions. This will pay you back in gold when you're looking at complicated or larger functions, as you will see. Now I haven't compiled it yet, but I will save it. And I'm going to do the same thing here, and I'm just going to cheat and copy it. In this case, I'm going to add the addend and change that right there. So I have a prompt, the enter addend, and then I have the data I want to get, %d, and then my ampersand says, put this in this data element here, send me the address of it, and I'll give you the data. And so we'll put that in there. I am going to save this, and we are going to recompile this and see what it looks like. Pull back up that command line operation, press enter, and we have an error. And it says addend first use in this function. Well, what does that mean? You probably already know the answer to this. I did not create an addend variable here at the beginning, so I'm going to put the addend in there. The undeclared first use in this function. Actually, that's pretty clear, but you will see it in other places where it's just not as clear. So I'm going to pull ourselves back up here again, see what this does. It looks like it has worked. I'll do my ls. My add program is down there. I'm going to come back here, and there it is right there. So I have an addition program. I can put 15 into there, 25 into there, and that's all that happens because that's all we've written into the program. Let's come here and finish this guy up. We're going to add the values. So we will add the values to a sum. And then we will display it. Now here's an opportunity to talk about another piece of printf. Here I'm going to again do another \n so it kicks it down, spaces it out a little bit. I'm going to say the sum of %d and %d is, and I'm going to do a %4.2f, and I'm going to do a couple of backslashes so we kick it down a little bit before the end. Now what I have done is I've made placeholders in this text string. The text string will be output as I tell it to, but instead of these placeholders there's going to be data. And that data I have to tell it as parameters. Every %sign has to have a data item here. So these are additional parameters. So I'm going to have the add end here, the aug end, and the sum. Okay. Now the sum is declared as an integer, and the system may complain about that. We'll see what happens. If it is, we'll turn it into a double. But because this is a floating point quantity, we'll see what happens, and this is worth checking things out. Now my shutdown really is just return success, and that's a return 0 there, so we'll put that there. We'll save this guy. We'll come back. We'll find out what the compiler thinks of what we did with the output. And it has sum. We didn't do that. I did mean to do that. Usually I make mistakes on purpose, but that's one I didn't. So we'll do comma sum. And again, I'm making that an integer to see what the compiler is going to do with it. And notice as format expects type double, but argument has a type of int. So we'll bring it back, and instead of putting sum in as an int, we will put it in as a double. The double will be okay with adding integers into it. That shouldn't be a problem. So we'll come down here again, and then we'll do our update, and it looks like that's worked okay. Now we can come down here and do our add program. We can do a 15 and a 35, and we get a 35 and a 15. Now I want to point out we get a 50.00. Let's see what caused that. I told it that I wanted a minimum of 4 digits in my output, and I want exactly 2 digits to the right of the decimal point. So obviously this has to be floating point to do that. So I said give me 4 minimum total. It could grow, but I wanted exactly 2 decimals, 2 digits to the right of the decimal, and in fact that's what I got right here. I got at least 4 values, 4 digits, and I've got 2 digits to the right of the decimal. So that's the use of fprintf. So now this brings us to the end of this very short operation here where we're writing the code for this, and we have our main. We've brought this through the 6-step programming process. We're going to expand on that as we go along, but you'll see that it's very helpful, and so we can move on from this, and we will end the program here.